We're going to talk today about managing security on AWS. And we'll start off by saying something that I hope is pretty obvious, but we'll say it anyway. At AWS, security is always our top priority. When we architect solutions, when we come up with new services, we make sure we're designed for security. We allow you to implement solutions that are constantly monitored. We try and aim for high automation, high availability, and obviously highly accredited infrastructure. And this gives you some benefits that AWS provides that you can take into your applications, your environments. It allows you to keep your data safe. It allows you to develop applications and services that will meet compliance requirements. It will help you save money, and hopefully it will help you scale quickly to meet requirements and growing demand. And to do this, we have a number of tools and features that we'll go into more detail throughout this presentation. We have a comprehensive identity and access control system. Obviously, security at the infrastructure level. Some very comprehensive inventory and configuration, stuff that hopefully will help you use stuff that implement solutions that will scale and work properly. Data encryption. So this is both data encryption at rest and in transit. Monitoring and logging is really essential capabilities when you're looking at secure environments. And of course, not forgetting our partner solutions. So services that make use of AWS infrastructure and provide additional insights and capabilities. And it's worth mentioning as well that when you use AWS, you get economies of scale that apply not just to cost, but also to security compliance. We have a number of very high-profile customers that are very demanding of our security, and we implement solutions that speak to those. But whether you're using that as a multi-million-dollar customer, or whether you just start out on the free tier, you will get the same security controls, the same security environment that our biggest customers get as well. So you benefit from the security, the economies of scale that we invest into our platform. So what does this mean for you? So you benefit from an environment built from the most security-sensitive organizations. We manage a number of security controls so that you don't have to. You get to define the security controls that are most applicable to your application and your requirements. And most importantly, you always retain full ownership and control of your data. That's really important to remember, and we'll talk again about that in more detail. OK, so what I'm going to do now is talk about something called the AWS Shared Responsibility model. And this is really key to understand how you can make best use of AWS and where the responsibilities lie between you as a customer and us as the service provider. And with us, we always say that security is a shared responsibility. You customers should concentrate on the systems and applications, while we, as AWS, look after, manage, and secure the underlying infrastructure. And there's a fairly detailed slide up there. I won't talk to everything, but if you can imagine that we look after the data centers, the facilities, the underlying networking, the storage, compute, networking infrastructure, the virtualization layer, and so on, that's our responsibility, and I'll talk a little bit later about how we demonstrate how we do that. But then you have the customer side of the shared responsibility model. This is where you get to decide how you implement some of those controls. When you build a virtual private cloud and configure your networks, you get to decide which networks are exposed publicly and which are private. You get to decide how you configure and install operating systems and applications on top of those services. You get to configure who has access to what through identity and access management services. And you get to control things like encryption and how that will work. But together, that combines to provide a framework that allows you to deliver secure, scalable services. So it's worth pointing out that quite often you may see one model for the shared security model, but actually there's a few. And it's worth pointing out the differences between them. So we have three sort of categories of service. Well, those we call infrastructure services, ones that we'll call container services, and ones that we call abstracted services. And there's different models for each. So if we look at an infrastructure shared security model to start with, so these are sort of our core platform services. Think of these as things like EC2, our virtualized compute platform. And if you see from the diagram, what we have is we have AWS global infrastructure, so our regions, our availability zones, our points of presence. And then on top of that, we have our core compute storage, networking, and database services. We're always responsible for those. We always look after the security and controls around those. But then when you launch a virtual machine in EC2, you become responsible for how you configure the operating system, whether you configure it with local firewalls, how you configure security groups, network access control lists, and so on. You're also responsible for any applications you install on top of that, and any customer data that you put into that. So that's a fairly straightforward shared responsibility model. We monitor and manage up until the hypervisor level. You're responsible for the operating system upwards. And that's a great starting point. However, what we really want to do is try and take away some of your undifferentiated heavy lifting, some of the additional security controls that, that may be burdensome for customers. And so what we have is a next set of services which we'll call container services, not necessarily containers, but container services. So think of this, the best example I will use for this is Amazon Relational Database Services, RDS. So in this example, what we do is we provide a managed database service, whether that's Oracle or Microsoft or Postgres or MySQL, a range of different services. We're responsible not just now for the underlying hypervisor, but as a managed service, we also take on management, patching, and securing of the operating system and the underlying network, and also the platform and application management. This means we look after the patching of it. We make sure that things are designed to be highly resilient. We provide options for you to deploy very quickly and easily. And then you become responsible for the data that sits on top of that, plus how you configure connectivity to it. So you can still have security groups applied to Amazon RDS, which will allow you to decide which of your virtual machines can talk to that database service, or whether you want to make that database service public or private, and so on. So that's our container service. And as you can see, the orange has gone a little bit further up the stack, meaning you have to worry less about that service. What we'll then look at is abstractive services. So these are the sort of highest level services we have. And this is where you can really benefit from some of our economies of scale and some of our ability to manage services at scale. And in this, what we do is we say we're responsible for the entire end-to-end service, including things like how we do the network traffic protection, how we offer things like encryption, so that may be through HTTPS endpoints. And then as a customer, you're responsible purely for how you configure authorization into that system, authentication into that system, and how you actually load and manage data on top of that. So example of this type of service, Amazon S3. We provide the capability for you to upload, store, and download objects, but you don't have to worry about how that scales. You don't have to worry about the configuration of that other than through things like bucket policies and IAM policies. And once again, it's always worth mentioning that whenever you see these diagrams, the blue is always customer data. This is always stuff that you control. You get to decide where things are put and where they're stored. So that's great. So we talked about three types: infrastructure, container, and abstracted services. What are the benefits of using some of those? And we really see some key benefits as you move to some of these higher level abstracted services for customers. The key one, and this I think is something that I've seen occur many, many times in government agencies I've worked with in the UK, it means that you can get away from having to manage infrastructure, and developers can focus on their core product. They're no longer worried about having to build the underlying infrastructure. They can make use of available, highly scalable, highly resilient, highly functional APIs. They don't have to worry about how they scale the infrastructure. They don't have to worry about how they make that infrastructure highly available. They can focus on building the core product, whether that's something that's commercial, whether it's something that's going to benefit citizens in the public sector, and so on. It also means that we manage the security of the underlying services. We make sure that patches are applied on time and to schedule. We do what we call, again, the undifferentiated heavy lifting. We look after all the hard parts so you can focus on the application. What this really does is this means there's reduced overhead, so developers can reclaim time and energy that can be spent on developing great products. It also means that we can allow developers to try lots of things, whereas before they might have spent 80% of the time building the platform and then 20% building the services on top. Now, all of their time can be spent on those services. They can try, fail fast, move on to the next thing, be very agile, and start developing things quickly. So let's give some examples of this to make it a little bit more real. So we'll start with a very easy one. So we're looking at real-time file processing. So imagine you have a requirement to upload thousands of files and do some transformations on those. You may want to take an image and make a thumbnail of it, or resize it, or change it to a particular file type, and so on. In a traditional environment, you might have built a scale-out cluster with some queuing services and then some applications that ran on top of that to process. In this environment, we have a very simple architecture. We allow users to upload objects to Amazon S3, our storage service, object storage service. What will then happen is through a configuration, it will send a notification every time a file is added. And that notification will trigger a number of Lambda functions. So Lambdas effectively are a serverless compute environment. It allows you to run code in response to events. The code runs, executes, then stops. You pay in 100 millisecond increments for what happens. And so in this case, it fires 3 simultaneous Lambda functions, or in parallel. One of those might do a resize. One of those might change to a different file format. One of those might take a thumbnail. And then together, they put the data back either into S3 as a new set of files, or they may decide to capture some metadata about what's happened and store it in Amazon DynamoDB, which is our NoSQL service. So what's key about this is nowhere in this infrastructure are there any servers that you have to manage, nowhere that you have to install or configure underlying applications. You write the code on your Lambda functions, and you're off and running. Let's take a slightly more complex example now. This is an example infrastructure for mobile backend. So you may have a mobile application that needs to interact with data and services that run in the cloud. In this example, we have mobile users that interact with another of our higher-level services called Amazon API Gateway, which provide RESTful endpoints that you can use to interact with other backend services or AWS infrastructure. And what is happening here is that we're authenticating using Amazon Cognito. Again, this is a service we have for user identity management, either through federation or through your own user data. What happens here is those APIs will make calls into different Lambda functions. So some of those functions might be to return business logic, some might be to update databases or so on, and they can go back to all sorts of different back-end services. So in this example, we have S3 again. We have SNS, which provides push notifications, so we can then start telling users what has happened through push notifications on Android or Apple or other devices. And then here we've got an example of stuff going into Amazon DynamoDB, and all the changes that are made are captured as a DynamoDB stream to another Lambda function, which then pushes data into an indexing engine. So again, looking at this entire environment, we've now got everything from an API gateway to user data stores to functionality to data stores to content delivery, all of which is running as high-level managed services. You just have to worry about designing and building the application itself. Last example, a real-time voting application. Here we're working with one of our partners. So for example, Twilio. They provide interactive phone services, whether that's voice or SMS and so on. What's happening here is you may tweet or message a phone number into API Gateway. That triggers a very simple Lambda function, stores the data DynamoDB, captures some data, and all that content is served through Amazon S3, which has the ability to deliver static websites. So you can serve up content from Amazon S3, have client-side JavaScript, which will then make calls into Amazon API. So you can build entire web applications without having to worry about or manage web servers and infrastructure. OK, so that's some examples of where abstractive services are really of benefit. But then we're coming back to the shared responsibility model now, and we want to talk about how we're going to apply that. And the best way to think about shared responsibility model are 2 phrases. Security of the cloud. That's AWS's responsibility. And we do that through security measures that we implement and operate. And we demonstrate those by certifications and attestations. So what we don't do are allow customers to come and visit our facilities. As a solutions architect, I don't know where our data centers are, and I'm not allowed access to those. It's not in my responsibility. I have no need to. And likewise, we don't do the same with customers as well. So what we do instead is demonstrate how we secure those facilities, how we secure our networks, and so on, using the standards and accreditation and certifications that I'll talk about in a minute. But then in terms of the customer responsibility, you can think of this as security in the cloud. So these are measures that you have to choose to implement. We provide a range of tools and services that I'll talk about to help that, but it's your responsibility to do that. And what we do is you build on our foundational services, but then we also provide some frameworks and guidance and best practice to help you with that process. And again, the focus of the second part of this talk will be on those. So let's start briefly with security of the cloud. So we have certifications and attestations. And these are effectively third-party audits of our infrastructure to demonstrate that we are doing as we say we will in terms of securing the infrastructure that we run. And they typically result in a certification or an audit report or an attestation of compliance. Now, we provide access to those through a service called AWS Artifact. So if you log into the console and look for AWS artifacts, you will find that you have on-demand access to all of the key reports and findings from a range of different compliance and attestations that we hold. That's globally available. Some will be region-specific. So if you're looking, for example, Cyber Essentials, those are focused on EU regions, so you'll only better download for those from the EU regions. But effectively, our infrastructure runs in the same security model globally. You can quickly use those to assess, and you can use those to build on your own security controls on top of the ones that we publish. So I've talked about alignments and frameworks as well. These are published security or compliance requirements or best practices that are required by a particular industry or function. So in the public sector, they typically are country-specific. They might be a requirement around how you secure infrastructure or where data has to reside and so on. And to help that, we have a load of functionality to ensure those security features are possible, and also enablers. So these are things like Quickstarts, mapping documents, white papers, that help you implement the security that you need following best practices. Just as an example, these are some of our assurance programs. These are global assurance programs, so they're applicable to all of our regions. And they range from things like the Cloud Security Alliance controls through some of the ISO standards for security, cloud security, personal data in the cloud. SOC 1, SOC 2, SOC 3, so these are where a lot of our our controls are audited and reported on. And things like PCI DSS. So if you need to handle payment card data, then we're level 1 certified for the infrastructure. Moving on to more sort of specific European and public sector requirements, we have things like C5, we have Cyber Essentials Plus, ENS High, G-Cloud, and IT Grundschutz. And if that's mispronounced, I apologize. But these are all sort of services or assurance programs that have been designed to meet requirements from particular countries or geographies. And again, we have many more of those. This, again, is just some of those to give you an example of the sort of controls we're able to maintain. If you have a requirement for those, for one that isn't on there, please come and talk to somebody wearing a black T-shirt, and hopefully from AWS, and we can talk about how we can look at meeting those requirements. OK, so that's security of the cloud. Much more critical for customers who are implementing services in many cases are how you do security in the cloud. And to help with that, we have a range of different capabilities. So these are some of our services that we allow customers to make use of to build secure services on AWS. I'm not going to talk to all of them because we'll be here all day, but if I just point out some key ones that you will undoubtedly come across. From a networking and security perspective, Amazon VPC is our virtual private cloud. This allows you to carve out a virtual portion of our infrastructure and use it to deploy your infrastructure, your virtual machines, your networking requirements, and so on. We have a range of ways of connecting into that. So Direct Connect is our private network connectivity, where you can plug 1 or 10 gig network connections into our infrastructure for high-speed, low-latency connectivity. We allow similar private connectivity over AWS VPN. Once data is in there, you can secure access to those virtual machines through things like security groups, network access control lists. And then you can wrap a whole range of high-level services around that. So if you want web application firewall capability, we have AWS WAF, DDoS protection, AWS Shield. If you want to be able to apply a range of different security controls from a firewall perspective at scale, we have AWS Firewall Manager. I'll talk about that in more detail later. Monitoring and auditing, if you want to see what's happening within your network, what type of connections are being made, whether they're being accepted or rejected. Flow logs allows you to get insight into that. So that's our networking and security portion. From a compliance and governance perspective, this is probably where new customers will see most benefit compared to an on-premises environment in terms of the capabilities that are offered. Because with services such as CloudTrail and Config, you are able to see in near real time all the activities that are taking place from an infrastructure perspective into your AWS account. This means that every time we make a call into AWS, every time you launch a new instance or you reconfigure a security group, that's done through an API call, and CloudTrail logs those API calls. It tells you who's done it, where it was done from, when it was done, what the action was, what the result was. And that's available in a log that you can audit and query and also automate responses to. And we'll come into that in a bit more detail later. So there's a range of compliance controls. We also have things like service catalog, which allow you to create pre-templated infrastructure environments and then allow users to deploy those even though they may not have the necessary permissions to instantiate that infrastructure themselves. So there are ways that you can do very sort of well-defined infrastructure to allow developers to build quickly, but without having complete access to every tool that AWS offers. From an identity perspective, again, we recognize that users will be wanting to store identity in a range of different places. So we have things like IAM, which is our Identity and Access Management Service. This controls how you can access the AWS APIs. But then we have things like Cognito, which allow you to federate with third-party service providers, and also with things like SAML providers. AWS Directory Service, which is a managed Microsoft AD service. AWS Organizations allow you to manage multiple accounts, AWS accounts at scale. And then we've got various options for things like Active Directory integration, SAML federation, single sign-on capabilities, multi-factor authentication, a range of different identity capabilities. And then lastly, we have a range of different ways of encrypting data and storing the key, and managing the keys that are used to encrypt that data. So KMS is our key management system. And what this does is allow you to manage your encryption keys that are used for a range of different AWS services. Secrets Manager I'll talk about a bit later. Cloud HSM is a single-tenanted environment which allows you to manage crypto keys securely using a range of different APIs. And then we saw also client-side encryption if you want to encrypt before you move to AWS. And Certificate Manager, which is a great tool, especially for public sector organizations. If you've ever been in a situation where an SSL certificate has expired over the weekend and your service has gone down, you'll know why. This allows you to provision and manage SSL certificates for free. Okay, so I'm going to give 3 use cases now as to how those tools can be used and why that is of benefit to yourselves. So asset and inventory management. To me, when I first started using AWS, this was the big draw. This was the fact that knowing every point in time what's running, where, and why. Because everything is an API call, everything's authenticated, signed, and logged, whether it's done through the console, whether it's done through a command line, whether it's done through an SDK, all of that is logged in CloudTrail. And it also means that we're able to then track that. Service Catalog allows us the ability to deploy those things in certain pre-templated environments. And then AWS Systems Manager is a service that allows you to manage fleets of instances and infrastructure on AWS, but also on-premises as well. So if you've got a few thousand on-premises instances and you've got a few thousand EC2 instances in AWS, you can use AWS Systems Manager to do things like patch those, to capture inventory on them, to manage parameters, to maintain a particular desired state, and so on. This was launched about a year and a half ago, and Systems Manager was massively updated at reInvent last year, our annual conference in Las Vegas in November. If you haven't checked out AWS Systems Manager and you're running any sort of scale on AWS, I highly recommend having a look at it because it offers a range of really, really good services. Okay. Another use case is network segmentation. So I've talked about virtual private cloud, the fact that within, once you create a virtual private cloud within AWS, you can create public and private subnets. So you can decide which instances are available on the internet, which are private to your infrastructure. You can control access through security groups, which you can think of as a stateful firewall that's applied per instance, and also network ACLs, which are stateless firewalls that are applied at the subnet level. The reason we have 2 means you can have separation of responsibilities. You can have a network team responsible for security of the subnets and what can talk between subnets, and you can have the application teams responsible for the security groups and which applications can talk to each other. So separation of responsibility, defense in depth. Monitoring all of that is a service called VPC Flow Logs, which will track what's happening within your network and the ability to monitor those and also programmatically react. So if you see suspicious network activity, you can automatically alert an administrator or even potentially do some automated remediation. In terms of how you connect, obviously over the internet is one way, but we also support IPsec VPN and private network connectivity using Direct Connect. For government customers that require connectivity to private networks, so in the UK we have things like the Public Services Network and our healthcare networks, we have design patterns that will allow you to connect to those as well. And we're happy to sort of talk to any customers who have that type of requirement and how we can help design that architecture to work. Lastly, configuration and change management. So one of the other key things, as I talked about with the APIs, are the ability to see what's going on. But you can also then, at any state in time, see what your current configuration is. Config rules allow us to take that one stage further and say, OK, here's what we think the infrastructure should be like. Show me any deviations from that. So you might have a requirement that every instance you launch has an encrypted volume. So the storage is encrypted. What we can do is we can create a very simple config rule that says all storage should be encrypted, and then it will initiate alerts and potentially auto-remediate issues where it finds that not to be in compliance. So if a developer starts up an instance that hasn't got it encrypted, config rules will spot that and send a notification. In order to help avoid those situations in the first place, and again, if you take away one thing from today, I would say that automation is your friend. Then we have services such as CloudFormation, which allow you to define your configuration and your infrastructure as code. You define that using something called a CloudFormation template, which is just a structured document that describes what resources are, how they're configured, how they talk to each other. And then that becomes the state that is deployed through CloudFormation and your infrastructure is launched. What it then means is you've effectively documented your infrastructure as well, and you can now version control it because you can store that infrastructure in something like Git or Subversion or some sort of repository. And then what you can do is any changes to that will be tracked. You can see who's changed what, when, how it was deployed, and so on. From an on-instance perspective, we have a service called AWS Inspector. AWS Inspector is an agent that you install on instances, and it will check to see whether the machine is patched properly, if there's any suspicious activity, if it follows best practice guidelines, and it can issue alerts if it finds infrastructure that doesn't occur to that. Trusted Advisor is a managed service we offer that automatically checks your environment to make sure it's following best practices. So we have a framework called the AWS Well-Architected Framework. Again, if you haven't seen that, I would highly suggest having a look. It talks about best practices around things like security, performance, reliability, cost optimization, and operational excellence. And what that does is provides a series of best practices and guidance in terms of how you should deploy your infrastructure and how you should manage your infrastructure. AWS Trusted Advisor will effectively look at your account and try and spot things where you're not doing that. So if you've got a bucket that is publicly available, it will flag that. If you've got, say, an instance that's bigger than it should be, it will flag up the fact that you could be saving money if you changed it to a smaller instance type. So that's a very good service. And then CloudWatch events I'll talk about in a minute. This all leads into a concept we have called security by design. And this is really a security assurance approach that formalizes what I've just talked about into your design, and then talks about the ways in which that design can be implemented, rolled out, and monitored. And what it does is really, instead of assuming that you will do audits at particular points in time, it helps to demonstrate that you are continuously audited. So using things like CloudTrail and Config, at any particular state and time, you can see that you are in compliance with the requirements that you have from a security perspective. And it does that really through 4 approaches. So you start off by designing your infrastructure, and that's typically through CloudFormation. You have templates, and those are deployed as stacks, which stand up your infrastructure. That stack will contain particular resources, applications, and so on. There are constraints. You can define who has access to what within that infrastructure. And then most importantly, how you deploy those, that can then be pushed into an environment which allows you to deploy things on demand. All of this is underpinned by the API. And so every interaction you have with AWS, as I mentioned, is through an API. And that gives a number of really, really great benefits. The first is it's authoritative. It's the interface you have into how you manage AWS, whether you're using that through the console, through the command line, the CLI. The AWS API is how you interact. It's auditable. So with CloudTrail, we know who's had access to what, how often, when, and so on. It's secure, so we require authentication. It's done over a secure link, so HTTPS. It's fast. You can get data back in sub-second time. It's very precise. So at any one point in time, you can ask to describe your infrastructure, and you'll get all the instances and their configurations, all your buckets, or your API gateway endpoints that have been deployed. It's continuously evolving. So as we release new products and capabilities, we make those available through the API and through the command line, and you can interact with those straight away. Provides consistency, and really importantly, it's automatable. So you can use that API to automate your best practices, to automate your deployments as you need. So here's one example. So this is an example of automated remediation, and it's using a service called CloudWatch Events. So the example is a customer wants to make sure that they don't have internet access available within a secure VPC. So they've built something. It may contain sensitive data. They may connect to it over a VPN. What they don't want is any way that that could be exposed publicly to the internet. And to do that, they want to ensure that there's no internet gateway attached to it. Now, initially, as the first layer of defense, IAM policies, so our identity and access management policies, can be created that have explicit denies that say, do not attach internet gateway to this VPC. But let's just say there's an admin who's done something they shouldn't, or an admin who's doing things they shouldn't. We want to be notified if somebody does accidentally do that. And as a bonus, it would be really great if the system could automatically detect that this was done and then remove it without user interaction. So how do we do this? Well, Amazon CloudWatch Events is one way. This is a near real-time stream of things that happen within the AWS API, and it describes changes to those resources. So you can use really simple rules to see when a new instance is created, when a security group rule has been changed, when an instance has been terminated, and so on. Or you can schedule something. So you can say every 15 minutes, do this. Every 1 day, do this. So some examples are you might want to respond to operational changes. You might want to send notifications. You might want to correct actions. You might want to schedule a daily snapshot of your production environment. So events are changes in your account. They're generated from other AWS services, or on a schedule, or from custom application-level events. Targets are what happens to those events. So once you've generated an event, what do we do with it? And we provide a range of different targets. So you may choose to automatically create a snapshot. You may choose to run an automation document, or you may choose to run a Lambda function. And if we remember, Lambda function is our event-driven serverless capability, which means you can write code to do anything. So CloudWatch can effectively trigger anything you can do in the API, which is really powerful, as we'll see. And then lastly, you have rules that match incoming events and routes them to the particular targets. So you could look to say, if I see this particular type of activity in this account, then target these targets. What we also now is support the ability for that to work cross-account. So if you follow some of our best practices when you work at scale and you have multiple AWS accounts, you can have a single AWS account that processes events from every other AWS account you have. And then you can programmatically react to those from that single account. I won't spend too much time on that because that's a fairly high-level scenario. This is what, sorry, let me go back. So this is actually what we're going to do. We're going to create a CloudWatch Events rule that triggers when we see a particular API call called EC2 attach internet gateway. And when it does, we're going to do two things. We're going to send a notification email to our security team, and we're going to trigger a custom Lambda function that will detach that internet gateway. In terms of how it's configured, this is the screen it looks, and it's quite simple as that. So this is the screen you use to configure that. It simply says we're going to look for the service name EC2 for API calls, which is attached internet gateway. And when we do, we're going to target two targets at the same time, a notification and a Lambda function. You can have multiple Lambda functions, you can have multiple targets, and you can define different types of events. You can ask so maybe attach internet gateway or change security group, a range of different capabilities. If you're interested in this, I'm around afterwards to answer questions or provide targets in terms of next steps and so on. But really, I've covered quite a wide range of topics in the first half hour, and so it's quite difficult to know where to start. So the last part of the presentation, I'm really going to provide some examples of where you can go for more information, where you can find best practices, and so on. And what we're going to talk about are the way in which we continuously innovate in response to customer demand. So I'm going to talk about 4 new services we've launched recently and how they can help with securing your environment. Quickstarts, AWS Answers, blogs, how we do our documentation, and then how we work with partners. So for continuous innovation, some services we launched recently, AWS Certificate Manager, so that's our managed SSL service, now supports the ability to deploy private certificate authorities within your account. So now not only can you create public certificates, but you can now manage private certificates as well. Firewall Manager. So I mentioned we have AWS WAF, our Web Application Firewall service. What AWS Firewall Manager does is allow you to define those that will work across different regions and different accounts. And then you can define rules that say whenever a new application load balancer is launched, it should have these rules applied automatically. And so you can enforce compliance across a range of different accounts simply by using AWS Firewall Manager. AWS Secrets Manager is a way of managing your credentials at scale. So these will allow you to manage credentials for things like Amazon RDS, our database service. You define an initial set of credentials, and then it will itself will automatically rotate those on a regular basis and provide programmatic access for applications to better retrieve the latest current password, the latest secret. We also support the ability to do custom rotations, so you can integrate that not just with Amazon RDS, but with pretty much any service that requires secret storage. Config rules I've talked about before, so this is the ability to say whether or not your application is in compliance, whether your infrastructure is in compliance with a set of defined rules. Config rules aggregation, as it sounds, allows you to aggregate results across multiple accounts into a single location, so you can see not just the configuration of a single account, but multiple accounts within your organization. And then lastly, this was announced at our reInvent conference in November. Amazon Guard Duty is effectively an intelligent threat detection and continuous monitoring system for your infrastructure. And it monitors a range of different capabilities. So it monitors how you interact with AWS. It monitors network traffic coming in and out. And it monitors DNS. And between all of those, it looks for suspicious patterns, and it looks for anomalous activities, and then flags up potential alerts. So this can include items such as port scans or attempts to brute force SSH, but it can also identify things like if you have public keys that should only be, or AWS access keys that should only be used within AWS. If somebody tries to use them from outside of AWS, it will flag that up as an issue. If it sees external connectivity from your application trying to go to a known Trojan or a known piece of malware, then it will flag that up as an alert as well. So this is something that is very, very easy to enable. It takes 3 clicks in the console to enable it in a particular region. And you can get very sort of great deep insight into what's happening within your network. So again, as an action from today, if you haven't, go away and try this. You have 30 days free trial on this as well. So you've nothing to lose. Just go away and activate it and see what sort of stuff is happening within your network. OK, Quickstarts. So AWS Quickstarts are pre-packaged solutions, typically deployed as CloudFormation templates, that have been built by AWS solutions architects and or partners. They help you deploy popular solutions, popular infrastructures on best practice on AWS very quickly, and they cover a wide range of topics, so everything from DevOps, security, to entire application stacks. Some that particularly focus on security, so we have a number of reference architectures. If some of these are US-based, some are UK-based, some are general. So here we're looking at things like how you follow NIST best practices or HIPAA-compliant infrastructures, how you look at deploying infrastructure in the UK that meets UK official guidelines. And then we've got some generic ones like PCI DSS if you need to do card payments, how that infrastructure might work. And then we've got some examples of partner solutions that do that. So if you want to deploy deep security, I'm Trender in exhibiting today. If you want to do in-depth network analysis using things like Palo Alto and Splunk, there are solutions that you can deploy very quickly. One example I will call out is something called the Center for Internet Security. They have an AWS Foundation benchmark. This deploys infrastructure into your account, which will check for common bad practices and help you alert for those. So it will look to see whether you've got your root account locked down or whether you've got IAM permissions too widely set, and so on. And that deploys an infrastructure that uses some of the tools I've mentioned, like CloudTrail, Config, CloudWatch, Lambda functions, SNS, S3, to monitor and store all of that infrastructure. All of that capability. And again, it's something you can deploy with just a few clicks into your existing account and start getting insights into what you're doing. One further example, this is NIST High Impact. So this is the ability to host sensitive data in the cloud, how we manage that, how it's deployed using proxies in front of a secure environment, how we use database for scalability. I won't go into too much detail now, but again, all of these links are available on the website. There'll be some links at the end of this, this presentation for you to see. What's really important as well, as you get more advanced with AWS, we've released a lot of guidance on how to build your own Quickstarts. So that's published on GitHub. That provides a number of best practices around how you should write CloudFormation templates that can be multi-region, multi-account specific, how you should parameterize CloudFormation, how you should name, how you should follow best practices, and so on. So really, if you're already using AWS and you're familiar with CloudFormation, this is a great next step to think about following best practices. AWS Answers. One quick show of hands. Who here has heard of AWS Answers? Okay, very few, maybe 5% of the audience. So for me, this is AWS's best hidden secret on the website, and I wish it wasn't. So AWS Answers, aws.amazon.com/answers offers clear answers to really common questions we get around architecting, building, and running applications on AWS. It's a repository of instructional documents and prepackaged solutions. And it outlines our best practices and provides some prescriptive architectural guidance, so how we recommend you do things. Some examples, and this is by no means comprehensive. How do you ensure that your AWS account is set up securely? You know, what are the steps you should follow when you create a new AWS account? How do you set up your identity and access management for your organization? What are the native security logging capabilities within AWS? How should I launch instances so they follow best practices for security? How do I control OS level access? How do I protect my application from DDoS attacks? So this is just one example of that. So here is a reference architecture for protecting a web application against a DDoS attack. We can see it uses everything from our DDoS protection, AWS Shield. It uses CloudFront, AWS WAF. We then look at how we use Shield at the application load balancer level, and then how we put stuff within security groups in private subnets. So, and that's followed by a range of different architectures for non-web applications and applications that can't sit behind CloudFront and so on. Lastly, another one that comes up all the time as a solutions architect, customers want to know how they centralize logging, whether that's within a single account or across accounts. So this is an architecture that builds a centralized logging solution for you. It allows you to visualize that using Elasticsearch and Kibana. It controls access to your dashboards, and it captures things like logs on instances, but also things like load balancer logs and so on. AWS blogs. So this is somewhere that's really useful to follow. Three that I've called out in particular. So we blog a lot, and we blog a lot from different teams. Three that if you're really interested in security and management, that I would call out security, our management tools, and our underlying architectural blogs have some really good advice and guidance on best practices. One example recently is how to use bucket policies for a defense in depth to ensure that the data that you store within S3 is stored securely and only accessible by the people you intend it to. So again, that's just one example. These are published on a daily basis. Documentation. So AWS's documentation is pretty good. What I would say is if you think it could be improved, or if you've got examples you'd like to make in terms of where something could be more clear, what we've now done is we've made the vast majority of our documentation available in GitHub. So if you want, you can go and make changes. You can make pull requests to submit feedback, to add examples, and our service teams are monitoring those, and we'll look to incorporate that as possible. So again, whilst we've got documentation on our website, the underlying source of that is on GitHub. And then last but no means least is our partners. Obviously, you've seen a number of those out in our expo today. But we've got a range of partners that focus on different types of capabilities, so whether that's infrastructure security, how you secure your virtual private cloud, how you log and provide advanced analytics in terms of what's happening within your infrastructure, identity and access control with third-party services, config and vulnerability analysis, and then lastly, data protection type capabilities. So all of these build on top of AWS security controls. So to recap, because I've got 5 minutes left. In AWS, security is our top priority. Key to understanding how that works is our shared responsibility model. So security of the cloud is our responsibility, and we demonstrate that through a range of different controls that are surfaced through documents that are available in Artifact. Security in the cloud is your responsibility, but we try and make as many tools and best practice guidance available to help you with that. Where possible, try and use abstracted services, so those higher level services where you have to do less management of the infrastructure and you can focus more on the code. Really automate things. Again, can't stress this enough. The more you automate, the less issues you will have because humans make mistakes. Once you've got stuff automated, you can then start writing tests against that and so on. And again, make use of all the available resources we've talked about today, whether that's best practices, whether it's Quickstarts, blog posts, and so on. So from our point of view, AWS Cloud is the new normal, and security is still pretty much familiar. A lot of the controls are the same. What it does provide is it typically improves security for nearly all customers because you have that instant, detailed insight into the actual state of your infrastructure, not just what the last audit of your data center said 3 months ago when you went around and counted all the servers in a rack. It really simplifies the work of security and compliance, especially if you can demonstrate that you've deployed infrastructure automatically, because then you can demonstrate that how you deployed that is secure, and therefore the infrastructure that was deployed has inherited those capabilities. It really delivers unprecedented visibility and control, not just in terms of what you've deployed, but how it was deployed and who deployed it. And it really enables agility and speed, because when you can automate this, when you're ensuring you're continuously compliant, that means you can start building stuff really quickly within those patterns, and you can continuously innovate. And with that, 2 links. AWSAmazon.com/security talks about a range of different best practices, and AWSAmazon.com/compliance will point you to all the guidelines and frameworks and attestations that I talked about. Other than that, thank you.